Hi everybody, today we are going to solve a problem in this video lesson, and the problem is from a concept called one-dimensional motion. First let me read out the problem so that we can start solving the problem. The problem is given like this. There is a car who is moving with a constant velocity. That velocity is given for you 20 meters per second, and the driver sees a stationary object at a distance of 100 meters ahead. So let us first understand what he is saying. That he is saying that there is a car moving. This car is having a constant velocity 20 meters per second, and this driver has seen an object. This object is stationary, and the distance between the car initial position and the object is 100 meters. So he has to apply the brake and not to hit that object. But for all these things to happen, this man will take some his time. Why he has to take time? He has to see the object, he has to visualize it, and then the message has to go to the brain has to respond. For all this it takes some time. The time is called reaction time. So during that reaction time, he won't do anything. He will be still rolling his car in a normal way. So what happens in the reaction time? The car will be keep moving. Let that reaction time is not known for us, delta t. Once if the reaction time is over, then he start taking a decision. Say here, let us say, so during that reaction time, he covers some distance s1. We don't know what is that. So still he has covered the distance s1, will be still having a velocity of 20 meters per second. Then he start applying the brakes here. Here he applies the brakes. Once he apply the brakes, it is given that the car will get a retardation of 4 meters per second square. Not to hit this object, finally the car has to stop. His final velocity has to become 0. So let us talk about this portion first, the second portion. He has applied a brake, retardation is there, and after covering a distance s2, the car has stopped. What is that I want to calculate? In that part, I can write an equation, v square minus u square equal to 2as. Finally the car is stopped. Initial velocity is 20. It has got a retardation, therefore minus 4. Distance is s2. So minus 400 by minus 8 is s2. So it is very clear that s2 is nothing but equal to 50 meters. So once he apply the brake, the car will stop after covering a distance of 50 meters. So this guy, being the total object is at a distance of say 100 meters, has a time that he can cover a distance of, total distance is 100, here he has to cover 50. So during the reaction time, he can safely cover a distance of another 50 meters. So how much reaction time that he has is, he is moving with a constant velocity 20 meters per second. He can cover a distance of 50 meters. So that he can start applying the brake exactly at the point of 50 meters. He will cover 50 meters and don't hit the object at all. Therefore I would like to say the driver has reaction time. The driver has reaction time until he covers the first 50 meters with a constant velocity. He is moving with a constant velocity 20 meters per second. So what is that value of S1 now I want to write? So I can write S1 as u into t That's reaction time. Half. There is no acceleration in that part or retardation in that part because he is moving with a uniform velocity. This S1 is 50 meters. He is moving with a velocity 20 meters per second and a time t. So his reaction time t is 50 by 20 or 5 by 2 or 2.5 seconds. So this guy can safely take a maximum reaction time of 2.5 seconds and then start applying the brake, so that he will go to a distance of 100 meters and stops just before he is hitting the object. So his reaction time, generally every human being will have a reaction time. A sharp guy will have a less reaction time, and little guy who is thinking something else while he is driving must be having a little more reaction time. But in this case, the best reaction time has to be equal to be 2.5 seconds. Thank you for watching. Keep coming for more and more video lessons. Thank you.